This video shows results from the research project SimProve. The research project deals with the linking of discrete event simulation and process mining for more efficient analysis and design of production and logistics systems. The project consortium includes the following partners. The SimProve research project is funded by the state of Hesse as part of the Distr program. The funding started in September 2021 and has lasted 2 years. This video shows how simulation can help process mining users explore what-if questions. The basis for process mining are event logs. The use of event logs, which contain only actual data, allows comprehensive analysis of logged past processes. However, how changes to the actual process affect process flows and events cannot be analyzed on the basis of past data. The concept presented here shows how simulation models can be automatically generated from past event logs with actual data. In this way, alternative target processes can be investigated thanks to simulation. The simulation models are generated with the help of services such as those provided by process mining libraries like PM4Py. These services allow the construction of process graphs from the event logs, for example as DFG files, as BPMN models or as Petri nets. They also provide functions for determining parameters such as the duration of processes or the transfer times of individual machines. The graphs and the determined data can be visualized via a suitable user interface before they are passed on to a simulation tool such as plant simulation. At this point, the simulation is used to validate the genetic model against the event logs, the real data. By starting the simulation, a model is automatically generated in plant simulation, simulated, and then the results are sent back to the application. In the present concept, this is also used to visualize simulation results such as the utilization of individual nodes of the simulated graph or the cycle time of entities through the graph. After the simulation has been performed, the results can be viewed in the application. The comparison of simulation and real data shows that similar KPIs are achieved in both cases and that the simulation is thus close to reality. The throughput times also show very similar values. The level statistics show that stock is built up in the system and only reduced at the end. This is an indication of a bottleneck in the system. Before machine A, stock is built up without being reduced in time. Thus, the bottleneck is located after this object. The bottleneck should now be removed by adjusting the graph in the application. For this purpose, another alternative is created in the application and a third line with machines is added. This optimized alternative is then simulated again and the results are compared. The comparison of the results shows that the throughput time has been significantly reduced. It can also be seen that the system fill level in the optimization alternative remains relatively constant without a backlog building up. These target actual comparisons are made possible thanks to the simulation-based event logs. This closes the circle described, and process mining can also be used for alternative process variants in the sense of a scenario assessment with the help of simulation.